Testing, testing, 1, 2, 3.
Yeah, there's the record lights. Yeah, it's on. Thank you. Of course, these slides are available in Blackboard under PowerPoint Slides Chapter 4. Okay. Let me turn on the pointer here. Skip over all this stuff. Okay, so as you remember from last time, a database is a collection of data. Now we know that data is stored in organizations all over the place, from Excel spreadsheets to Word documents to in people's heads, right? Data is stored everywhere. But organizations often need to have a centralized storage facility for storing data that's related to each other. And that's where a database comes in. We're going to be using a database tool from Microsoft called Database Access. And for those of you who have Windows machines or parallels with Windows on it, I can show you how to download Access for free so you don't have to come here and do your work. The rest of you, however, keep this in mind. This project is not something you can really sit down and do in one sitting, so I strongly recommend you get a flash drive so you can save it, save your project. I am not certain whether you can email the file to yourself. However, in the 50-point access project, the assignment itself, I'm going to leave that Dropbox open. Okay? So if you're desperate, you can upload your halfway done project to the actual assignment, because the only one I grade is the very last one that you turn in. All right? So you can upload your Access project to the assignment and then go to another computer and download it and get it. All right? So a flash drive or upload it. Flash drives are better. Databases are used when we have multiple themes. What does that mean? Well, I had mentioned to you that for your grades, I download them from Blackboard into an Excel spreadsheet. And that's a perfect application because Excel does math, for one thing. And secondly, it's all one item. It's student grades, right? Student grades. But if we have a much more complicated scenario that we want to save data, for example, all the universities in the United States, all the classes that they teach this fall, and all the students that are taking those classes, that is a much more complicated scenario, and it absolutely can't be put in just one flat Excel file. It's impossible. So Excel is just a two-dimensional table. It's got the column headings, right? And then each row represents a student. You know, there's a student and their grades. So what I did was created a separate document, and it's also in the Documents folder, way down at the bottom where it says Access. And I'm not going to go through all of this again, but relational databases are a way to store lots of information that has different themes, right? And I already mentioned the university example. Now, I want you to look up here, especially those of you who weren't here. So what we tried to do on Tuesday was, we tried to just create a fictitious Excel spreadsheet that had all the universities and their information, all the classes that are being taught and their information, and all the students and their information, and we tried to put it into one big file. It's impossible to do. There's way too much data. Not only that, more importantly is, we don't know which students are attending which classes. All right, we don't know that. So this is a really good slide or a page on my Word document that you should study. So if I put all the universities in one spreadsheet, all the classes being taught at all the universities in a different spreadsheet, and all the students taking classes this semester in a third spreadsheet, then it's more manageable, okay? So, obviously I don't have all the information we would store about universities. In the real world, we would store the university name, the president, the location, the phone number, the web page, and each one of those would be columns, correct? Likewise for class. We're going to put the class name, the description, the teacher, the room number, the hours, all that kind of stuff. That's going to go in this table. And last, everything about you as students. Your name, your major, maybe who your advisor is, all that kind of information. But I do want you to look very carefully at this. The very last column is critical, and I mentioned this on Tuesday. The very last column is critical. Even though the university's classes and students are stored separately, the very last column is a link, a hook, a way to look back at a previous table. So if you'll just look up here, we can see that this ITM220 class, this one right here, it's information systems, right? And it is being taught at UT. And the corresponding record number for UT is 01. This is critical. Critical. This class is being taught at 01, which is UT. It links them back together. That's a relationship, right? Likewise, Bugs Bunny is taking class 01, which is this class, right? So this very last column tells us what it links back to, what class it links back to. And subsequently, we can look here and figure out which university he goes to. So it's all hooked together. Does that make sense? It's all hooked together. Okay, one of the issues with Chapter 4 is that there's a lot of new terminology that you guys have to know for the exam, and because you need to know it, period. Your homework assignment for this weekend is to create an entity relationship diagram of a database of your choosing. So, an entity relationship diagram is just a picture of something. That's why I said you can hand draw it, right? It's a picture. And so, with entity relationship diagrams, or ERDs, we have things called entities. Each one of these, university is going to be an entity, class is going to be an entity, and student is going to be an entity. So that's a new word that you need to know. Entity. It's only used when you're creating ERDs, entity relationship diagrams. Entities contain attributes. Attributes. University ID is an attribute, university name. So all of these fields are attributes, okay? So we use the term entity when we're creating an entity relationship diagram, a database model, and we use the term attribute to describe the fields that we're going to store when we're creating the model. Now, if we take a step backward in time, and you might remember this from Tuesday, we actually created an entity relationship diagram of universities, classes, and students. So if you'll pause for just a moment, and one of you guys turn the lights on, can you hit pause on the recorder? Okay, in order to create your entity relationship diagram, you're going to have to start with a sentence. And you guys get to be creative and choose whatever it is that you want to do for your database project. So we'll start with what I have. We have universities, classes, and students. And now we have to think. We actually have to think for a moment about how are these related. That's why it's called a relational database. So we start with the biggest. There are many universities. Okay, there are many universities in the United States. Each university has many. So each university has many what? Classes that they teach, correct? So this is going to be classes. And each class hosts many what? Students. If you can even get this far, you're doing great. This is your relationship. There are many universities. Each university has many classes, and each class has many students. Okay? Now, you're going to circle everything on the end, and all of these are going to be entities. Okay? Entities, because we're creating a drawing. Entities. All right, so I'm going to erase this so we don't have to move the camera. So this is what you're actually going to do this weekend. Whether you do it using a drawing tool or hand draw it, take a picture of it with your cell phone and upload it, I don't care, as long as I can read it, all right? All right, now this can be a little bit tricky. I want you to think about all universities. And here's the question. All universities have one question mark. Okay. This is what we want to store about universities. What's the most obvious thing? The name, right? We want to store the name. Each university has one and only one. What else?
ID.
An ID. Very good. That's going to go up here. Always. Always. And we'll get to that in a minute. What else do we want to store about universities? Their name. What else?
Their address.
Address. And let's just say, for example's sake, one more thing. What else?
Number of students.
No, actually, that's a good idea. I'm glad you said that. We're going to be able to count the number of students because we're going to have the students over here. And if a student drops out, then this is going to have to be constantly updated. So we don't want that. So what else do we want to store about each university? Faculty, yeah, that's a whole different attribute.
What kind of university it is? Private, public?
Okay, great. Okay, university type. That's perfect. Okay. All right, let's do the same thing here. You always start with the name of the attribute followed by ID. And you can abbreviate if you want to. Same thing. all students have only one what? Every student has only one. It's most obvious.
Name.
Name. Oh, stupid. I didn't finish my coffee. This is my bad. Classes like ITM220, actually class sections, right? So think about this class. It has one what? Let's talk. Think big. It has a name. Class name. Class what? What else do we need to store? Class name.
Syllabus.
Syllabus. Class. How about this room? Location, right? How about me? Class teacher. Last and first. Okay. Now we're back to students. So for every student, what's the most obvious? Student what? Name. Last and first. What else do we need to store about students? We already have your student ID, your student name. That's going to change. It's not as good. How about the year that you started, okay? Because that's going to dictate which catalog you're going off, right? What else is unique to you?
Major.
Major.
That's not changed too.
Pardon?
That's not changed too. That's not changed too. You change changes.
Okay, but that's okay. Well, at one time, you're only going to have a major. Maybe most of the students aren't going to change majors, but you could. Let's just think of one more just for fun. Tyler, what else do we store about students besides their name, what year they started, their major,
Their birthday.
date of birth? Perfect. Student date of birth. So far, so good. We're well on our way. Okay. Down here at the bottom, we have a very important field. First of all, before I even go to that, the sentence that we wrote earlier said, each university has many classes they teach. This little diagram in the middle that looks like a crow's feet, this represents the word many, all right? And each class has many students in it. This represents the word many. This is the relationship. So it means that these two are hooked together and these two are hooked together. So that's where this comes in. If we have a class ITM220B, it's obviously related to a university, right? How do we know which one? Do we put the university name down here or abbreviation? No, we don't put the abbreviation. We put the ID. Okay? So we're going to call it class university ID. Likewise, we need to know what class the student is attending. Okay? So we're going to put student class ID. All right. Let's get into a little bit of terminology. Each one of these, again, is called an attribute. An entity. Right? University, class, and student. each one of these have a name. What are they called? Entities have attributes. Entities have attributes, right? Every entity has got one field that uniquely identifies each of its members, each of its universities. Okay? That field has a name. This is called the primary key. This, and this. Those are primary keys. So last time we talked a little bit about primary keys. They're usually numeric, auto number, and we talked about student ID. That's how you're identified here. And there is no relevance to your student ID. It's not like a combination of your birthday and anything else, right? It's just a number. But it's your number, okay? And really all it is the next student that gets accepted at UT is given the next consecutive number. That's all it is. I told you guys the story of how my mother had requested Social Security numbers for us 3 kids, all at the same time. Now you have to get it at the hospital. But our Social Security numbers are very close together because they're just consecutive, right? So every one of these entities has a field in it, an attribute in it, that's called a primary key. A class ID is going to uniquely identify a class. A student ID is going to uniquely identify a student. All right. Down here at the bottom is what's most critical. That's called a foreign key. Very last field. And it's also numeric. A foreign key. And lo and behold, this is not hard at all, although right now might seem complicated, but let me get a different color here. But watch this. All it is, if these two tables are related, all you do is take this primary key and copy it down here. And we're just going to put the name of the attribute or the entity in front of it. Okay? Because these are related, we're going to take this primary key and drag it down here. And ditto for this. That, ladies and gentlemen, is the foundation of relational databases. And I know it may be confusing for you right now, but this will make a lot more sense when we get into Access. You know how pivot tables, they didn't make really any sense until you started doing them? Right? Same thing here. Same thing here. But while I have this on the board, this is just a drawing. This is a database design drawing, right? Database design. From this, in the real world, a systems analyst would get with the users and design how things are related and what we need to store and why, okay? And then we come up with this database design. Then the users would agree that this is what we believe is true, okay? Once the users sign off on it, the next step is to actually create the database. So when we're in the design phase, they're called entities, right? And attributes. Entities and attributes. When we go into the design, to the actual creation of the database, they get new names. Entities turn into tables. Okay? Attributes will turn into fields, or we can call them columns. Fields or columns. Right? Fields or columns. That's when we're actually creating the database. One other thing for your homework you need to know, you should definitely get this, take a picture of it with your cell phone, I don't care what you do. There's one other thing that I'm going to require of you for your homework assignment. And I'm just going to have to squeeze it in here. All right. The primary key is going to be auto number. It's going to be auto number. Each one of these fields has information about it. What kind of data does it hold, right? What kind of data? So, what kind of data is named? Is it a date field? Is it alphanumeric? Is it numeric? What kind of data does university name contain? Is it numeric? No. It's alphanumeric, right? Text. What's the longest university name you can think of? How long do you think that needs to be? 30 characters, maybe? 40? We're going to say text. Text 40. All right, what about university address? That's also going to be text, maybe 40. City, 30. State, 2. Zip, we're going to make it, even though it's a number, we're going to say it's text, 5. And university type is also text, I don't know, 20. So all these things right here are going to be required for each one of these. And they have a special name, so you should jot this down. This is not a name that you've ever heard before. It is called metadata. Metadata is just a term that means it describes the fields. What kind of data they are, how long they are, okay, metadata. So for your homework, this is kind of what I want. Obviously, this is pretty messy, but you're going to sketch this out neatly so I can read it. And each one of these fields is going to have metadata on it. Now, here's a good question. If this is numeric, auto number, what does that tell you about the foreign key? They're the same, right? Although it's not really auto number, it's going to be numeric. Always. Okay. Very good. All right. Yes, sir.
For the metadata, you have written text 40, or whatever. Is that verbatim what we need to do for our homework? When
Yeah.
we write it down, we just write out how many characters we use?
Right, the maximum number.
Okay.
And why do you think we do that? Well, I'll tell you one thing right now. In Access, the default is 255 characters. Do we really need 255 characters for university name? No. But if we reserve 255 characters, that's going to be a lot of wasted space. Wasted space turns into slowing down accessing your database, okay? So we want it to be as long as it needs to be, but really not any longer, all right? So if you would point the camera back over here. So you can see how this correlates to the entity relationship diagram we have. We have the university ID, that's the primary key, the university name, and we have a lot of other fields too. Only what I'm showing you here is the actual table. This is the next step from the entity relationship diagram, is where we actually create the tables and the data. And that's what you're going to be doing for your second homework assignment. First part is this, and the second part is like this, except it's going to be in Access, sir.
Is that handwritten?
Yeah, you can handwrite it, or you can use something like Microsoft PowerPoint or Publisher to make text boxes.
Are we getting our own data, or are we getting
No, you're going to create your own database and your own data, which I'll help you with ideas. Don't panic about that. All right, so here we go. This is the class entity, and this is actually the class table, and these are all the attributes, and attributes turn into fields or columns, and ditto for student. And the thing that I really want to emphasize most to you guys is that if you can understand the concept of a foreign key, this field hooks back to this table. This field hooks back to this table. If you can really grasp that, you've got it. Sometimes I get students that no matter what I do, they just don't, it just doesn't click. Sadly, it just doesn't click. Okay? And I'm glad to bend over backwards to help you in any way. And here is an example. You know, you're obviously welcome to take a picture of that screen, but this is just a very abbreviated example of an entity relationship diagram. University name, text 100. We said text what, 40 over there? Class ID, class name, text 10, so on and so on. This is what I'm looking for, except for this arrow is going to look like the crow's feet. Right? No, the primary key is always going to be the very first column, and I like to put the foreign key at the very end. Okay, it's just a convention, right? All right, so is the screen's turned towards the projector? Okay, would you guys hit the lights? Now we're going to move on with the regular PowerPoint slides. And there's another example. In this case, we have a teacher that wants to store student grade information, and also every time a student makes contact with a professor, okay, through email or office visits. Why would they want to do that? Okay, here's a good example. If I have a student who challenges their grade, and maybe they go to my boss and say, well, I emailed her 5 times and she never replied, then I've got the documentation here that says that's just not the case. Okay? Or they came to visit me, if I've got that data recorded, it's just for my benefit. Right? That's just one reason. So if you look up here, similar to what I showed you with the university's classes and students, we have student spreadsheet, and this is actually very much what your spreadsheets look like when I download them to Excel. Okay, they've got your name. I don't care about your student number, but I do have all your grades here. Right, some of them are blank because we haven't done it yet. Over here, and this is a little harder for you to see, are student emails and student office visits. Student office visits. Now, this entity relationship diagram is slightly different. Okay, what's the main entity? The beginning entity, do you think? Something has something else. What is that first something going to be? Students, right? Students. This one is going to be your main one, right? Students make, send emails. Students send emails. But unlike the entity relationship diagram we have over here, where something has many somethings and that has many something else's, this is just a little bit different. So turn the light on for just a second, and I'm not going to draw out all the data in anything, data. I'm just going to kind of make some boxes here. And this time in the middle, so did you point over here? Point a little bit over this way. We have student. And a student has many what? In this example, email. A student sends many emails, right? A student does many or has many visits. So this is what your entity relationship diagram would look like, where the main entity is in the middle. Whereas in that one, it's something has many somethings and that has many somethings. This points out that way. For your database, I don't care. As long as you have two relationships, I don't care what you do. Don't worry about that because I have lots of ideas for you guys. Okay, point me back at the main screen. This is going to be student and grade spreadsheet. Turn the light off, please. This is going to be an email table, and this is going to be down here at the bottom, an office table. Okay, I want you to know this definition, and it will definitely be on the exam. Database is a self-describing collection of integrated records. So, you know, I love textbooks definitions because you still are clueless what it really means. So I'll tell you. Okay? Self-describing. What does that mean? Well, I'll tell you what. We're going to name this table emails. So it's obvious what's in it. Emails. This one's going to be students, so we know it's about students. And that one's going to be visits, and it's obvious it's about visits. That's what makes it self-describing, the names that we give things, okay? It's just about naming things. Integrated records. Back here, each row in a table is a record, okay? And therefore, Andrea Baker may have one or more emails that she sent, and Andrea Baker may have one or more office visits. That's why they're integrated. Integrated means related. Okay, related. So, what are databases made of? The actual data. The data in the tables. Of course, it all comes down to characters, which are bytes. We knew that from the previous chapter. And each column in the table is called a field, right? A column is a field. When we're drawing it, it's called an attribute. But when it's actually in Access, it's called a field. A row in a table is a record. So remember that R equal R. It's an easy way to remember. Row equal record. One record. Like one student, or one university, or one email. A row is a record. A table is the entity, right? And we're going to have 3 separate tables in this example. And the data is what you actually type in. That you type in. And you guys are going to be typing data for this assignment, but it's really not going to be a lot. I'm not going to force you to create tons and tons of data. So each one of these columns is a field in the student table, and each one of the row is an individual student, which is a record. So every row represents one record. One university, one student, one email, one office visit, depends on the table, right? Each row represents one unique item. Now we're getting back to the primary key again. For each row of a table, you have to somehow uniquely identify that. So for you guys here at the university, we differentiate you based on your student number. Do you remember we said about banks? How does a bank know John Smith from a different John Smith? Account number, right? How does the IRS know which taxpayer John Smith is which? Social Security number, okay? Those are called primary keys. They help to uniquely identify things, okay? Primary key. It is a value that identifies any particular row. It's usually the very first column. It's the table name followed by the word ID. Student ID, university ID, email ID. So it's the table ID. That's what we call it. And the metadata is going to be auto number. Every table must have a primary key. In fact, Microsoft Access is smart enough that when you create a table, it automatically assumes the very first column is your primary key. Auto number. Yeah.
So like a foreign key would be just like, but a primary key is a value that I have to reserve.
Yeah. Well, we'll get to that one next. The batteries are starting to get low here. Now we're going to talk about relationships between tables because this is a relational database. Remember, we can't store it in one big giant Excel spreadsheet, right? We've got to break it down. And these breakdowns are going to be into tables. And these tables are related to each other. It's all about relationships. How can we tell all of the office visits or all of the emails that were sent by a particular student? Well, the answer to that question is the foreign key. Okay? The foreign key is a value or a column, the last column in fact, the last column in a table. And all it is the primary key from the table it's hooked to. That's it. There's not magic to it.
Is it the last column or the last row in a column?
Well, in your entity relationship diagram,
Yeah.
it's the one at the bottom, okay? But when it's actually turned into tables, it's going to be the very rightmost column,
Okay.
okay? All right. So this is the concept that you really have to understand and grasp. It is a field, the very last column, okay, that tells us what the relating table, what the relationship is to the relating table. It's almost always numeric, the metadata, and it is the hook between two tables. It is the hook. The foreign key is the hook. It is the relationship. This is one of my favorite slides, if you just want to make a note of it. And plus I added a lot of stuff to it. I want you to look at this, and if you can really absorb this and understand it, you are really doing great, okay? So in the middle, again, we have student. Here we have our student table. The very first column is the student number. It should be student ID in my book. Up here we have the email table, and the very first column would be the email ID. I always call things IDs instead of numbers. And this is the visit table, and here they use visit ID. They're not being consistent. But anyway, 3 separate tables with data in them, right? So a student can have 0 or many emails. A student can have 0 or many office visits. Okay? So if we look at Andrea Baker, that's her student number, right? How do we tell if she sent any emails? Because student table is related to email, right? We're always going to look at the foreign key. Remember, the foreign key is just the primary key from the table it's related to. So look, student number, right there. And it's always the last column. So we know that Andrea sent 2 emails. Why don't we put her name? Somebody knows that the answer. Why don't we just put Andrea Baker? So
There might be another Andrea Baker.
there could be multiple Andrea Bakers, right? There could be. Just think of it like John Smith. There could be multiple John Smiths, right? So we're going to put their number because their number is unique. Ditto for office visits. We have Adam Rivera, right? And he visited 1 time. How can we tell? Because his student number is in the foreign key. Student 1325, which is Andrea, she was a busy bee. She sent 2 emails and she also visited. Then we have 3559, which is Jeffrey Tam. He also visited. So the purpose of the foreign key is it's the primary key from the table that it's related to. And it helps us book things together, right? Now, does the very first table have a foreign key? Think about it. Think with your brain.
First table?
Yeah. No. Because it's not related back to anything, right? It's relating forward if it's not relating backward. So, first table is never going to have a foreign. Make a note of this slide number 11. It's a good one. Okay, Micah, would you pause, please? Got the screen in focus. Is it okay?
Yeah, if it's not focused though, is there a way to focus this thing? I know it's kind of old, so I can't really tell.
I'm right at you.
So you use that thing.
Yeah, I'm just going to zoom
Okay.
in. Okay, that's good. All right, guys. I wanted to pause because you have this little assignment due this weekend, so draw a line across your page, and this is going to be how to create your entity relationship diagram. The first thing I'm going to do is go to Blackboard assignments. And here is the Blackboard assignment, ERD -3 if not done, all right? And again, the first thing you have to decide is what database you're going to do, which we'll get to in a minute. And either hand draw or use Microsoft Publisher. Word isn't the best choice. However, PowerPoint does a really good job because you can move things around in PowerPoint really good, easily. Group them all together and save it as a JPEG. That's really easy to do. Or take a picture of it with your cell phone. I don't really care. But I just want to talk briefly about what the requirements are. First of all, you have to have 3 entities, which are going to end up being 3 tables. And they have to have 2 relationships. Now you can have the main table in the middle pointing outward, or like the one on the board earlier, this has many that, and that has many other things, right? It can go in one direction. I don't care. Either way, it's fine with me. Okay. Now, each entity has to have 5 attributes or fields, all right? Each entity has to have 5 attributes or a field. And I know it's kind of dark here and you can't really see it, but For this one, for university, for example, name would be 1. Now, this is very important. Address is always broken up into separate fields for a lot of reasons. Even though it's going to be university address, university state, city, zip, even though it's technically 4 fields, I consider it 1 because they just belong together. Right? Also, name. Separate last name and first name, and I consider those as 1. And last, I don't count the primary or foreign key. So you have to have 5 fields. 5 fields. And remembering that some fields are combined, and I count them as 1. They belong together. And you don't count the primary or the foreign key. So yours is going to be longer. All right. I also, again, you have to have 2 relationships with the crow's feet. The primary key must be at the top, right? And the foreign key is going to be at the bottom, and I want you to actually draw a line that points to them. This, draw a line, points to the foreign key. This is where a lot of students go wrong, and I know it's simple, but a database is a self-describing collection of integrated records, and the part self-describing is very important. And when I was a software engineer, this is how we did things. If this is the university entity, each attribute is going to begin with university or some abbreviation of UNIV. Does that make sense? This is a class entity. Everyone is going to begin with class. Every one of them, including the foreign key. And ditto for student. I don't have it on here, but and I need to add this. Next to each of the fields, I want you to tell me what kind of field it is. Is it date? Is it numeric? Is it text? Is it auto number? And if it's a text field, how long it needs to be. Okay? That's the metadata. That's the metadata. So I will add this to these instructions. So what's the hardest part? Thinking of the database. Right? So what I have you guys do is try to think of something that interests you. Maybe the field of work that you're going into, or a hobby, or something like that. And again, you can hand draw it very neatly, take a picture, and upload it.
When you pay the data, because I think one is that we have to go like 40, but is it always have my pen or is it not?
No, it doesn't matter. The default is 255 characters, and that's too long for most fields. So the second place I'm going to go is to documents, and then way down at the bottom is access. And the reason I'm going here, I know this is difficult to read, and I apologize, but you can read it if you get on Blackboard. These are ideas for databases. There are many actors. Each actor can play in many films. Each film can have many supporting staff, such as directors, etc. There are many daycares. Each daycare can have many parents of children, right? And parents can have multiple children. That makes sense, doesn't it? They belong together. There are many hotels. Each hotel has many customers. Each customer can have multiple bookings, like for in the future. Same thing for flights, just thoughts. And I'm not going to go through all these. Many companies, each company has many departments, and each department has many employees. That's very hierarchical sort of arrangement. Anything that you can put in a hierarchy is going to be perfect for a relational database. Okay. There are many vehicle manufacturers, and each manufacturer can have many models, and each model can have many options. Or you can have manufacturers have dealerships, and dealerships have many customers. There's lots of different ways to look at these things. Okay? I'll just do a couple more. Holiday rentals. There are many cottages. Each cottages have many rentals, and each rental has many people in the cottage. And there are other ones there. Now, I think all of these are in the format of this has many that has many that, kind of in that one direction. But I would like for you to think about something that interests you. However, let me tell you, the university students' classes is off limits. We talked about that. I also am not going to let you do sports teams players. Way too easy. Plus I get a lot of those. So you're going to have to get creative about what you want to do.
So I know we can't do the classes, but can we use another aspect of the university?
Okay, like, do you have a thought?
Like the different food plans, like we have different restaurants that all have different meal exchanges, that kind of thing.
Yeah, that would be perfect.
Okay.
That would be perfect.
Okay.
Okay, can you pause the recording for a moment?